Go. All right, Brooklyn, this is 2-5. Homework assignment I have at the top of the page, page 188. Those guys. Looks like a lot of problems, but it's really not, actually. 4 through 32 by 4s. That's only, I don't know, however many problems. 5, 6, 7 problems plus 6 more. Anyway, not too bad. Fundamental theorem of algebra. Sounds like a really, really big deal. Are you ready for what the fundamental theorem of algebra says? Let's say, for example, let's do one of these down here. 1, 2, and 3. Example 1, example 2, example 3. If I graph those guys, this first one, how many places should he cross on at maximum?
2.
This guy, number 1. I look at the degree. 2. He could cross a maximum of 2 times. Now, he may only touch once. He may touch none at all. But on maximum, he can cross twice.
Yes.
My x-axis, okay? This guy, maximum, how many could he cross? Number 2.
3.
3, because the highest power is 3. So maybe he has 3 x-intercepts. Maybe he has 2. Maybe he has 1, whatever. The maximum amount he can cross is 3. This last one, max amount he can cross is 4. Okay, maybe he only crosses 2. Maybe he crosses 3. Maybe he crosses 1. Maximum he could cross is 4. That is what the fundamental theorem of algebra says. Okay, the degree of the polynomial determines how many x-intercepts on and at maximum he could have. Okay, the linear factorization theorem, that basically says this: if I can, when I break him down, he will break down into that many factors. Okay, so like I write my factors like this. So this guy can be written as a product of 2 factors, like this. This guy can be written as a product of 3 factors, etc. Okay, that's what the factorization theorem says. Okay, what they want us to do is find the zeros of each. A 0 is the same thing as a root, so if they call them roots, if they call them solutions, they all mean x-intercepts. I'm trying to find the x-intercepts. To find the x-intercepts, you plug 0 in for y, right? And the y-coordinate is f of x, so we're plugging 0 in for y, and then we're just solving. How do you solve x squared minus 6x plus 9? Like, how are you going to do that?
Simple.
What?
Is it simple?
It is a simple trinomial, because there's just x squared. There's no number in front of the x squared. So, is there a number I can multiply to get 9, but when I add them, give me negative 6?
3 and negative 3 and negative 3.
Negative 3, negative 3. X minus 3, x minus 3. If I set them equal to 0, x equals 3, and x equals 3. So how many places does this guy touch or cross?
2.
But they're the same number.
1.
So just once. Trick question. Sorry. He's coming down and he's touching 3. So 1, 2, 3 is where he touches, and he is a smiley face or frowny face?
He's smiling.
Smiley face. So he's going to look like this. Okay. You don't necessarily have to draw it or graph it. So maximum he could have was 2. That's what the fundamental theorem of algebra said. Okay. But he really actually only has 1, because 3 and 3 are the same one. Okay. Good?
So do you have to write like 1 or
So they say find the zeros of each. You can just put x equals 3. You don't necessarily have to list them twice. Okay? Number 2. I want to plug 0 in for y there as well, or 0 in for f of x. How do I break that thing down? X cubed plus 4x. What are you going to do there? X cubed plus 4x. What can we do? X cubed plus 4. Take out an x. We can do that. And we are left with x squared plus 4. And then, is x squared plus 4, is that a difference of squares? Why not? It's not a difference, right? It's not subtraction, so we can't do that. But we can just set each piece equal to 0. So if I set this guy equal to 0, I'll just have x equals 0. Then I have x squared plus 4 equals 0, and I want to solve him. Okay, are we doing okay so far? Okay, to solve this guy, let's subtract the 4.
Plus and minus.
So I have x squared equals, hold on, negative 4. And I take the square root. What's the square root of a negative 4?
4i.
Is really plus and minus 2i, right? So I have an imaginary number. So how many places does he cross or touch the x-axis? Really only once, right? He crosses at 0. He touches at 0. Don't forget about him. But these guys, this means he doesn't cross an additional 2 other times, right? Maximum he could cross is 3. So they're just saying these 2 are imaginary zeros over here. So he really only ever touches once. What?
Will it ever equal more than that?
No. More than the highest power?
Yeah.
No, that's what the fundamental theorem of algebra says. At maximum, he can touch 3 times. This one only actually touches once. Okay? And then the third one, x cubed minus 1. What? Or excuse me, x to the 4th minus 1. What?
You just skip this one.
Can I skip this one?
Yeah. So you
No. This way. This guy is a difference of squares. So the square root of x to the 4th power and the square root of 1. What's the square root of x to the 4th power?
It's 1.
X squared, x squared. Okay. 1 and 1. So I have minus plus. This guy is a difference of squares again. So this guy can break down into x plus 1, x minus 1. Oh boy. All right. Now let's set each one of those equal to 0. So if I set the ones that I just did equal to 0, x plus 1, this guy will be x equals negative 1, yeah? X equals positive 1, okay? If I set this guy equal to 0, subtract the 1 over, x squared equals negative 1, take the square root. What will that guy look like? The square root of negative positive negative I, okay? So he was supposed to have 4 answers. He does, in fact, have 4 answers, but how many places does he actually cross or touch? Only twice. These 2 right down here in this corner, the right ones, are the only 2. These other 2 are imaginary. Positive I, negative I, those are imaginary ones, okay? So he's really only actually touching twice, okay? So when you have higher powers, like 4th power, and he only touches twice, that means the other 2 are imaginary, or, like in the first one, the other one is a repetition of the one that you already have, right? Like 3 and 3. So it's either a repeating value or an imaginary value if you don't have as many as you should. Does that make sense? Okay, good? All right, rational zero test, P over Q. Do you guys remember P over Q? No? Not really? P over Q? When you are factoring things down that are really gross and you have no other strategy to do, you do the P over Q method. Yeah. P is the factor of the constant term. Q is the factor of the leading coefficient. Okay, so we'll talk about those here. Okay, so up above here, we had some sort of strategy for finding the zeros, right? On the last 3 that we did, we had some sort of strategy. Either breaking it down, pulling an X out, something like that, right? But example 1, 2, and 3 here, these ones are really ugly and really long, right? Like, how do I factor number 2 down when it has 5 terms? Okay. Number 3, I could try and factor this guy down by factor by grouping, right? And pull stuff out. But I will tell you that it's not going to end up working. There's no way that I can make the inside pieces of the parentheses match each other. So that's not going to work, okay? So what do I do when it doesn't work? I do the P over Q method, okay? Are you ready for this? Mm-hmm. P over Q. P is the constant term. Whoop. So the constant term of this guy, which one of those 3 pieces is the constant term? It's the 1. This guy is going to be your P. The constant term is the one that doesn't have an X attached to it, okay? The leading coefficient, what's the leading coefficient of this guy? Is 1 here also, so this is Q, okay? Let's label the other ones. Number 2, what's the P value here? Negative 6. Q is 1. Okay. Down here, P is 3. And Q is 2. Okay. All right. Now, what do we do with those guys? We do P over Q. So this guy is 1 over 1. All right. Now, here's the deal. 1 over 1. I list the factors. This guy says factors of 1, factors of 1. What numbers go into 1? What are factors of 1? What numbers go into 1? What? 1 and? 0. 0 doesn't go into 1. 1 and 1.
Negative 1.
But also negative 1, right? Negative 1 times negative 1 will give me 1 as well. So positive and negative 1, right? Positive and negative 1.
Is this
right?
1?
Yep. if you take positive and negative 1 divided by positive and negative 1, you're going to end up with positive negative 1. You just like reduce, right? If it's a positive 1 divided by a positive 1, it's going to be 1. If it's positive 1 divided by a negative 1, it's going to be a negative 1. Negative 1 divided by positive 1 is negative 1. Negative divided by negative is going to be a positive 1, right? It's either going to be a positive 1 or a negative 1. Okay, now, what this means right here, this answer that we get, this is all of the possible roots that this guy could be, which means that if it is not in that list and it's a whole number, it is not going to be a 0 of this equation. So like the number 3 is a whole number, but it is not in my list. So 3 is not a place where this guy crosses. 7, negative 7 is not in my list. That means negative 7 is not a place where he crosses. Now, I don't know necessarily that he crosses at exactly 1 or exactly negative 1, okay? But I can figure it out by plugging 1 and negative 1 into this equation here, okay? So if I plug 1 in here and here, if I plug a positive 1 in, 1 cubed plus 1 plus 1, that gives me 3. Positive 1 is not a 0. If I plug negative 1 in, negative 1 cubed plus 1, that gives me 1. Negative 1 is not a 0 either. So the ones that I just said that were possible ones, neither of them actually work.
Wait, if you plug negative 1 in, why is the second negative 1 a positive?
What?
If you plug in negative 1, so the first one's a negative 1.
Oh, sorry. The second one is negative 1 also. So this should be a negative 1. Right? What does it need to come out to be in order to be a place where he crosses?
Yeah.
It has to come out to be 0. So neither of those work. So does that mean he doesn't cross at all? It has to cross once. That means it doesn't cross at a whole number. It crosses at a decimal, probably like at the square root of 2 or the square root of 3 or something like that, right? Okay. But the rational zeros, rational means there's non-fractions, non-decimals, that type of thing. Rational, whole numbers, okay? He is not going to cross at 1 or negative 1. He is going to have really ugly ones. So find the rational zeros. This one doesn't have any rational zeros. No rational zeros, okay? So he crosses at places that are ugly, okay? Number 2 now.
Why do we have to do 20?
I don't know.
And here's our homework.
Because we have to do factors of the last number, don't you?
What?
You have to do factors of 6 on this one.
Yeah. Yep. So this one is P over Q. So P is negative 6, Q is 1. Factors of negative 6. What numbers go into negative 6?
1, 2, 3, 6.
Positive negative 1, positive negative 2, positive negative 3, positive negative 6. Yeah? The bottom, what numbers go into 1?
1, negative 1.
Positive negative 1, right?
Did you cancel?
So if I do plus minus 1 divided by plus minus 1, it's just plus minus 1, right? 2 over 1 is just 2. 3 over 1 is just 3. 4 over 1 is just, 6 over 1 is just 6.
I remember this.
Yeah?
This is, and then you
So,
get a number
how
at the
many,
bottom as
these are the
well.
possible ones. These are the possible ones, which means if it's not in this list, it's not a possible one, like 5. I know he does not cross at 5, because it's not a possible one. How many possible nice numbers do I have?
8.
8, okay? How do I figure out which ones of those actually work?
Yeah, plug them all in.
You gotta plug them all in, okay? Do you wanna divide and conquer?
I don't wanna do it at all.
You wanna do it at all? Okay, here's what I'm gonna do.
Homework problem?
Just wait a second. Okay, I'm going to do this real quick. Desmos. I like Desmos a lot.
Hey, we're close to see
Okay.
what you're recording.
Read me. What?
We're close to see what you're recording.
Yep, she can. Okay, read to me that equation here in just a second when I get this all typed and ready to go. Because I'm gonna find a place or show you how to
Oh, yikes.
do this really nice.
Oh.
F of x. Okay, read me that equation. Equals
X to the 4th
x to the 4th
minus x cubed
minus x cubed
plus x squared
plus x squared
minus 3x
minus 3x
minus 6.
minus 6. Okay. Because I've named it f of x, now I can say f of 1, f of negative 1,
Or you can just look at the graph.
f of 2. I could just look at the graph, right? F of negative 2, f of 3, f of negative 3, whoop, and f of 6, and f of negative 6. Okay, now which ones of those work? Negative 1 and 2. The other ones do not come out as zeros, yeah?
Yeah.
So negative 1 and 2 are two of my answers. Negative 1 and 2. The other ones do not work. Okay, now how many possible places is he going to cross? Total.
2.
Could he cross?
Mm-hmm.
How many possible places could he cross? 4? You see that? The highest power says 4, right? So he could cross a possible of 4 times. So either the other 2 are imaginary ones or they're really ugly decimal ones. Does that make sense? Okay, let's see by the graph what it is. Okay,
Nope, it's only 2.
what are my other 2 then?
Not there unless they're all the way down.
Unless they're all the way down, but I don't think they are. I think he just goes on forever up. So what are my other 2 zeros going to be? Imaginary. Okay, so they are not ugly decimals. The other 2 zeros are imaginary. Does that make sense?
Mm-hmm.
Okay. The only 2 places he's crossing is at negative 1 and 2. Okay? Because when I plugged them into that thing, which I cheated and I did by Desmos because it does it really nicely fast for me, negative 1 and 2 is where you came out. Okay? All right. Last one of this type of P and Q thing is 3 and 2. So we have 3 over 2. Whoop. 3 is my P, 2 is my Q. Factors of 3 are plus minus 1 and plus minus 3. Factors of 2 are plus minus 1 and plus minus 2. Yeah? So now, 1 divided by 1 is 1. So plus minus 1. 3 divided by 1 is plus minus 3. But then also, 1 divided by 2 is plus minus 1/2. 3 divided by 2 is plus minus 3/2. So how many possible rational zeros are there? 8, technically. If it's not in this list, then it's not a place where he crosses. Like the number 5, or the number 2 even, or the number 10. Those numbers are not in that list, so that's not where he crosses. He could cross at a really ugly decimal place, but these are going to be the nice places that are possible ones where he crosses, right? I'm going to check these. I'm going to use Desmos again. Somebody read me that graph, would you?
2x cubed.
Shoot, I shouldn't have done that. Undo. 2x cubed. Hold on. It takes a second for my keyboard. There we go. 2x cubed. Okay.
Plus 3x squared.
Plus 3x squared.
Minus 8x.
Minus 8x.
Plus 3.
Plus 3. Okay, I had to plug in 1, negative 1. I didn't have to plug in 2, right? 2, negative 2. I did have to plug in 3, negative 3, right?
Yeah.
And then I have to plug in
1/2 and 2.
1/2. So f of 0.5. Whoop, 0.5. F of negative 0.5. F of 1.5. F of negative 1.5. Okay, which ones work?
0.5.
Oh, there's 3 of them.
-3,
1,
and 1.
negative 3, and 0.5. Do you see those? Yeah? 1, negative 3, 0.5. Okay. Those are the ones that work.
Those are all 3.
1, negative 3, and 0.5. How many possible could we have?
3.
3. And we have all 3 of them. Okay, so that means there are no imaginary ones, no repeating ones. Yeah?
Yeah.
Okay. Shall we wait for the rest?
Yeah.
Okay. All right. You should be able to do some homework problems with that information. We'll do the backside tomorrow. Okay? All right.